Alright, so we have a sleigh being pulled by a constant force along a rough horizontal surface. Okay, and it's speeding up. How many forces are acting on the sleigh? Okay, so problem 3. And we're going to do part A. So we have a friction force. Since we have a rough surface, we have a friction force. We have the weight of the sleigh, which this force is by gravity, goes down. Then we have a normal force, and we have the pull force, which will go P. So this means we have 4 forces. 4 forces in total. And then for part B, okay, so then for part B, let's see what we got. The work done on the sleigh by the force of gravity. Because gravity is pointing down, right? And the sleigh is being displaced in the right direction. So there is, so gravity force, right? Is it gravity? Yeah. Okay. So gravity has force perpendicular to the displacement. Therefore, the work done is 0. Okay? Work equals 0. Okay, part C. Alright. The work done on the sleigh by the normal force. Well, we have the normal force right here. It's pointing up at a 90-degree angle. So, normal force, right? Normal force is 90 degrees perpendicular to displacement. Therefore, W is 0 again. And now we go to part D. Okay, part D. The work done on the sleigh by the pulling force. Okay, so we have pulling force and produces has positive displacement. Well, the pulling force is in the same direction, right? We have it right here. Pulling force is in the same direction as displacement, as D. So we'll just call it D. Therefore, so W is positive. Okay. All right. Now we go to part E. The work done on the sleigh by the force of friction. Okay, well, friction, it's going against us. The sleigh is moving to the right. Friction force is slowing it down. So for part E, friction does negative work. Right, friction force does negative work. Opposite direction. Direction. To displacement. Displacement. Okay. So the negative work. Alright. That's the answer. Alright, now we're gonna go to F. Let me just put F right here. Okay, let's see. F says the network done on the sleigh. Oh, the network done on the sleigh. Okay, the whole. So all the work combined, right? Well, it's given in the very beginning that the sleigh does move. The sleigh is speeding up. So because oh my god. It's given that the sleigh is because it's given the sled is speeding up. Does it's moving and to the right. It's moving to the right. It's moving to the right. The net was it? What was it? The net force? Was it the net force? What's the question? The question is the net force. Okay. The network on the sleigh. Okay, so the network, because it's moving to the right, the network is positive. The network is positive. Alright. And then for G, okay. The kinetic energy, well, since the sleigh is speeding up, right? Because it's speeding up. Accelerate. Kinetic energy is increasing. Kinetic energy increases. Increases. Kinetic energy increases. And now we have part H. Part H. We have quite a bit. So part H. Find the net force acting on the sleigh. Okay. So we're given over here that K is 1/2 mv squared, right? So K, right? It's given over there. K equals 1/2 m times the velocity squared, right? So you have the mass times velocity squared, right? And the force net, therefore, okay, force net is just going to be 1/2 times m times your times your velocity, right? You have your velocity, your final velocity. But this is just going to be minus the other velocity. So one way we can do this, I'm just going to write it over here, is your force net. It's just going to be equal to half, right? Half what? So we have half times your m, right? And then you have v2 minus v1, right? Squared, of course. So we have that, right? And then we have our displacement, okay? So this we can rewrite it. And we'll make it look a little nicer. I have force net equals, well, we can rearrange, and we can say we have 1/2, right, m, and then we have times v2 squared minus v1 squared over s. But we can still use some algebra, and we have f net equals, you can take the 2, bring it down here, put 2s over here, take that one out, you have an m standing over here, and you can just have v2 squared minus v1 squared, right, over 2 displacement times displacement and m, okay, and this could, this is basically the, the f net, and that's for your, each. Now, for problem, what goes after I? For I, we have find the work net done on the sleigh. Okay? The work net done on the sleigh is just F net times displacement. So we're going to write them in terms of F net and S. So we just write F net. So we have W. Okay, so we have problem I. So W net is just going to be your F net answer times your displacement. Okay. J. So for J, we have combined the results from H and I to find the net work done on the sleigh. So we're going to break it all down, right? So for part J, we're just going to take this W net, the F net part, and we're going to write down what we got over here. This F net, we're going to write this answer down. But we're going to add to that the S, the displacement we found over here. So we just write that down as is. So we have V2 squared minus V1 squared over 2 S. We have our M over here, right? S. Just like that. Okay. And it's part K. Okay. So for part K, we have a car of mass accelerating from V1 to V2 going up a slope that makes an angle, right? So this is similar to what we just did with the sleigh speeding up, being pulled. So it's very similar. Okay, very, very similar. Right? So, same thing. It's basically the same thing. So for the final part, we want to know what is the work done, right? For part K. So W can just be written by V2 squared minus V1 squared, right? All over 2, but we don't have the displacement given in the problem. So this is it. And we have our n over here. So that's the work done. And that concludes this problem.